Hello. In this video, we're going to continue learning about identities. And just like in the last video, the best way to learn how to do identities is really just to do them. Now, there are some techniques in terms of using different formulas from the formula sheet or some different algebra techniques regarding splitting the denominator or turning everything into sine and cosine. But in general, there really isn't a tried and true method for a particular identity. You just have to try something, and if it doesn't work, try something else, and if that doesn't work, try something else. So I'd encourage you to pause the video and give it a try. If you want a hint, I would say that looking at this identity might be worth considering maybe the identity on cosecant. If you remember, cotan squared plus 1 is cosecant squared. So if you move the 1 to the other side, you could do something on the right-hand side. So that might be my hint for you, but pause the video and give it a try. All right, so hopefully you gave it a try. Like I mentioned, we have our basic identity that says that cotan squared theta plus 1 is cosecant squared theta. So if I move that to the other side, I get cotan squared equals cosecant squared minus 1. So over here, that means that entire right-hand side just becomes cotan squared x. Now, on the other side, I know that well, I'll leave it as a cos, but cosecant is 1 over sine squared. Now, if this is a cos, it's really like a cos over 1. So cos squared times 1 is cos squared x. Sine squared times 1 is just sine squared x. And on the right-hand side, cotan squared is cos over sine. Because cotan is cos over sine, so cotan squared is cos squared over sine squared. And there we have it. Left-hand side equals right-hand side. Now, again, if you solve this in a different way, you're still correct. For example, you didn't have to do the rearrangement on this right side. You could have instead done something like this. You could have subbed in directly for cosecant squared. So you could have written this as, instead of cosecant squared, cotan squared x plus 1, and then left the negative 1 right here. So there you're plugging in entirely for cosecant squared and leaving the negative 1, but then the plus 1 and the minus 1 cancel out, and you still just have a cotan squared. Alternatively, you might have been able to do something on that left-hand side, but I think this is probably at least the most efficient way of solving this particular identity. All right, here's another one. We have cos x minus cotan x over cotan x equals sine x plus tan squared x minus secant squared x. So pause the video and give it a try. All right, now hopefully none of you did this, but I just want to point it out. These two cotans cannot cancel. The reason they can't cancel is that this is subtraction. If this was multiplication, then we would have one term on the top, one term on the bottom, and you're more than welcome to cancel. But because we have subtraction, we have two terms and we can't cancel it. And in fact, if we did cancel it, we would just get, what, a cos x? That's not going to be useful. There's no identities for cos x. We're just going to kind of just left without any options. So not only is it incorrect algebraically, but it's going to give you problems. It's not like this cheat is going to help you. It's actually going to hurt you because you'll never be able to get to that right-hand side. So let's not do that. But we could do something similar. We could take this fraction and we could split it up as cos x over cotan x minus cotan x over cotan x. Remember, if we have one thing in the denominator and two things in the top, we can kind of uncommon those common denominators, or split the fraction if you were. Now the cotan over cotan, that'll be a 1. And cos over cotan, well, this is a little tricky. Maybe we'll turn that cotan here. I guess it's like a 1 over cotan, so we could write that as cos x times tan x. 1 over cotan is tan. Then maybe write the tan in terms of sine and cos. So sine over cos Now here we've got something legit, right? The times cos divide by cos, those can cancel. So we just have sine x minus 1. That's looking pretty good on the left side. Now on the right side, well, remember we have an identity for secant squared. It's going to be tan squared x minus 1. Or sorry, plus 1. And that'll be all in brackets, so we have to subtract it. Sine x plus tan squared x. So that gives us sine x plus tan squared x minus tan squared x minus 1. And then we're left with sine x minus 1. All right, left-hand side equals right-hand side. And again, sometimes you work a little bit on the left, a little bit on the right. But the reason why I stopped working on the left was I had a sine x, which looked like this sine x. And so I figured, well, both those terms there, these two were good to go. So I was just going to leave the sine x there. If you notice, leave the sine x, leave the sine x, leave the sine x, because it's already the same on both sides. But then I wanted to work with everything else and try to get that into the negative 1. Let's go ahead and try another one. We have 1 over 1 plus tan squared equals cos squared over cotan squared times tan squared. So pause the video and give it a try. Okay, so on that right side, I think we can work with sines and cosines. I think that'll be easier. So we have cos squared x divided by, and then this whole bottom part we could rewrite as, well, actually, the cotan is kind of like a 1 over tan. So we could maybe write it like this. And then these would just cancel out. So we'd have cos squared x divided by 1, which is just cos squared x. Now on the left side, we have 1 over, and this is a pretty standard identity, secant squared x. Now 1 over secant, that's going to be the same as cos, and there we go. Left-hand side equals right-hand side. Okay, cos x plus 1 over sine cubed equals cosecant x over 1 minus cos x. So pause the video and give it a try. So this one's a bit tricky. The sine cubed is almost too much. A regular sine we couldn't do an identity with. Sine squared we would be good to go, but sine cubed? For this one we're going to need a little insight that sine cubed can be written as sine times sine squared. See, the sine cubed also doesn't work with the identity. Remember, the identity is sine squared x plus cos squared x equals 1. Or in other words, for our example, sine squared x equals 1 minus cos squared x. So we're going to need not the sine cubed, we're going to need to break off one of the sines. So we just have the sine squared. All right, let's go ahead and replace the sine squared with 1 minus cos squared. Now this is kind of a neat trick. 1 minus cos squared actually factors. If you think about this as a difference of squares. Okay, if you saw something like 1 minus x squared, you would factor it as 1 minus x, 1 plus x. So 1 minus cos squared, that actually factors as 1 minus cos x and 1 plus cos x. Now the reason I do that is 1 minus cos x, not super relevant, but 1 plus cos x and cos x plus 1, these are the same thing. So we can go ahead and cross them off, and we get 1 over sine x times 1 minus cos x. Over on that right side, cosecant is the same as 1 over sine x. And so we can kind of just sneak that into the denominator. And there you have it. Left-hand side equals right-hand side. Again, this is maybe a bit of a new technique. If you have a sine cubed, you can break off one of the signs so you have your sine squared, and then you can use your identity like normal. All right, sine cubed minus cos cubed is equal to this mess. Again, if you're looking for a hint, I would recommend you multiply out that right side and then just see where it takes you. So go ahead and pause the video and give it a try. All right, so we'll get sine x minus cos x plus sine squared x cos x minus sine x cos squared x. Now, again, this is it's a little tricky because it doesn't quite look like that. The right side, the left side, they both look pretty tough, but we could do that trick we were talking about before. We could write this as sine x, sine squared x, and we could write this as cos x, cos squared x. And for each one of these, we could substitute in our identity. So sine is 1 minus cos squared, and cos is 1 minus sine squared. Now, it doesn't look totally like the right side, but I mean, let's multiply everything out and see what we get. So this will give us sine x minus sine x cos squared x minus cos x plus cos x sine squared x. Well, I think we actually have the same thing. We just don't have everything in the same order. So we can just take that negative cos and put it second. So we have sine x. That's the same as that. Minus cos x. It's the same as that. That last term, cos x sine squared, we could write that in the other order. So the sine squared could come first and then the cos x. That looks good. And then here we have a sine x cos squared x. Okay, awesome. Now, just to show you another method, if you didn't want to do it that way, what you could have done is taken the sine squared and the cos squared on this side and use the identity over here. So you can just pause right here. You can see, obviously, left-hand side equals right-hand side. We're done. But just for fun, I could have, kind of not done any of this stuff. And instead, I could have done 1 minus cos squared x, cos x. And here it would have been minus sine x, 1 minus sine squared x. Over here, I got sine x minus cos x. Now watch this. We get a sine x. Here we get a plus 1 times cos will be plus cos x. And a minus cos cubed x. Here we get a minus sine x. And we get a plus sine cubed x, because sine x times sine squared is sine cubed. Now this cos cancels with this negative cos. This minus sign cancels with this positive sign. And all we have left is sine cubed x minus cos cubed x. And now this equals what we had at the very beginning. And so, yeah, we could say again, left-hand side equals right-hand side. So you can almost see like two methods here, right? Method 1 that I did was where I worked a little on the left and a little on the right. In method 2, I was able to work completely on the right-hand side, just expanding and then using identities. And eventually I got the sine cubed and the cos cubed. So we got another one here, tan x plus cos x over 1 plus sine x equals secant x. Go ahead and pause the video and give this one a try. If you're looking for a hint, I would recommend a common denominator. Okay, so what do we mean by common denominator? Well, tan, that's going to be sine x over cos x. Here we've got cos x over 1 plus sine x. And the right-hand side is just a secant, so that's just a cos x, 1 over cos x. So if you think about it, this right-hand side has one term. This left-hand side has two terms. So whatever we're going to do, we should probably just get one term. That means we need to multiply this by 1 plus sine x, and this by 1 plus sine x. Multiply this by cos x. Multiply this by cos x. So that'll become sine x, sine squared x, cos squared x, all over 1 plus sine x cos x. Now you might be saying, well, this is looking a lot more complicated than when we started. Maybe we're going down the wrong path. And sure, it does look worse, but now we have one big fraction instead of two smaller fractions. And by doing that, we're actually going to be able to notice something. We didn't have any squareds earlier, but now we have a sine squared and a cos squared. That's good news, because this right here has an identity. Sine squared plus cos squared is just 1. So I have sine x plus 1 over 1 plus sine x times cos x. And I mean, we can put this in brackets so we can see the sine x plus 1 over the 1 plus sine x, that cancels out, which leaves me with just a 1 on top, sort of like a placeholder 1, over cos x. And there we have it. The left-hand side equals the right-hand side. All right, we'll go ahead and take some notes on this. Again, we're still just doing trig identities. Trig identities. But we have encountered a few new techniques that might be worth writing down. One is if we have something like maybe sine x over cos x plus 1 plus cos x over sine x, right? It might be nice to do a common denominator. It's a good skill to make the denominators common, because it helps out sometimes. Similarly, if you have sine x plus 1 over sine x, it might be nice to split the fraction. In this case, we would have sine x over sine x plus 1 over sine x. So our fraction skills of either making a common denominator or splitting the fraction, doing uncommoning the denominator, both are very useful for trig identities. Additionally, another technique we saw was if we had a sine cubed x, we can split off a trig power. And so we get maybe sine times sine squared. Remember, the identity that's kind of our bread and butter for this unit, the sine squared cos squared equals 1, it only works for squareds. So if you have just a sine, it doesn't work, it's too low. If you have a sine cubed, it doesn't work, it's too high. It's got to be just right. It's got to be a squared term for it to work. And we've also seen stuff like this where you have a cotan x over maybe a cosecant x. It's nice to convert to sine and cos. Convert to sine x, cos x, right? Those are kind of like your basic ones. They're just really useful. The other stuff, cotan and cosecant, they can just be a bit more cumbersome to work with. So it's nice to convert everything to sines and cosines. Those are some good techniques. So go ahead and pause the video and give this identity a try for your notes. All right, so hopefully you gave this one a try. It looks hopefully obvious to you that common denominator is the way to go. The right-hand side just becomes a 2 over sine x, and there's really nothing else to do on the right side. But on the left side, right, we could multiply the top and the bottom by 1 plus cos x, or sorry, 1 minus cos x. Multiply this side by sine. So that'll give us sine squared x. Ooh, that's a lot of FOIL on that right side. I guess that'll be 1 minus cos x plus cos squared x all over sine x times 1 minus cos x. Just as another rule of thumb, when I do the common denominator, I often don't multiply out the denominator. This is just kind of like a little tip. Don't multiply out the denominator. It's not that you never multiply out the denominator. Sometimes you can, but you're going to see in a second that leaving it the way it is nice because something's going to cancel. So I have a sine squared plus a cos squared. So let's go ahead and group those up together. So sine squared plus cos squared. Then I've got plus 1 minus 2 cos x over sine x 1 minus cos x. Now remember, sine x plus cos x is 1. So 1 plus 1 minus 2 cos x. For me, when I start to see the answer here, it gets really exciting. I can see that something's going to factor and cancel, and I feel like I'm on the right track. 1 plus 1 is 2, and we can then factor that 2 out from the top. So I'll leave us with 1 minus cos x. And this is what I'm talking about. It was nice to leave it unfactored because now there's a 1 minus cos x there that we can cancel. We're just left with 2 over sine x. And the left-hand side equals the right-hand side. Now you can go ahead and try your own example. This is Unit 7, Worksheet number 3. And then any things to remember. Again, if you're looking at writing out all of those sine and cosine ones, remember that 1 over cosecant, I guess maybe I'll start with just the cosecant. Cosecant is 1 over sine. Secant is 1 over cosine. Cotan is cos over sine, or if you want, it's also 1 over tan. And then when you see the other options, right, if someone shows you a 1 over cosecant, that's just going to be a regular sign. If a 1 over secant shows up, you betcha that's just a cos. And if for some reason you're given a 1 over cotan, that's just a tan, or sine over cos. And of course, all of these could be squared if you wanted. It's true in general for just a plain cosecant or a cosecant squared or cosecant cubed and so on. All right, hopefully you enjoyed this video, and as always, thanks for watching.